and we run into the phenomenon where actually the YouTubers are much better at that. They don't ask me why start soon is up if the stream hasn't started. They don't understand my my own interpretation of what starting means. All right, so for Node Red, weather. Oh yeah, I was gonna do blood glucose on this one, but I think what I need to do is go into the node manager. How do I do that again? I don't remember how to use this program. Configuration nodes. No, that's not the right one. Stream Deck. No, no. Oh yeah, that's different. That's not what I want. Manage palette. Install, and then we're looking for the weather channel COVID-19 tracker. Oh, that would have been a neat one to put in. All right. Node-RED contrib TWC weather. So that's weather underground and the weather channel. One thing I don't know how to do is send a value for text in OBS. So we'll see what I can do with that. So what I would do is go down here. I got to get rid of that Twitch one. That's not a valid one. PWS and the weather channel. 7-day daily forecast, health forecast into a debug. I gotta find out what song this is. This is a good song. It's only from a mix that's... I'm looking for a date. 3 years old. I want to get headphones, man. This is a bop. I'm appreciating this. I got to figure out what kind of music I want to make with the 505, and if I'm even capable of making music in the first place. Yeah, if you guys don't know, right now I'm playing Space Cowboys, Deckard, my definition of chill. It is only audible to those who are on Twitch. Twitch allows me to have a separate track that doesn't make it to the VOD, and that way we don't run into copyright strikes, and I'm able to play stuff. So, yeah, the best feeling is finding new good music, and I've been doing that. I haven't like exercised that muscle of finding cool new music, and so I am a dinosaur. I've been using Link to Me by the Discord. The people in Discord linking music, awesome, love it, because I get to listen to new interesting stuff. And somebody linked what is it, like racing around to early 2000s drum and bass from like video games. So I had that mix for a few weeks as the intro music. I loved it. Oh my God, what's going on? Hype train, hype train, hype train, hype train. It's all the hype train subscriptions failing. So if I deploy... Oh, I don't have credentials in here. Oh, I need a PWS API key. API key. And we need to do location and language and name. Okay, that's not ready to go. Let's just turn that off. I'll look into this later. I love the PS2 mixes. Perfect neutral background. Yeah, for like getting stuff done. That's what a friend of mine told me. He like during his, and I never discovered this. This is not me. During his whole academic career, what he would do is he'd sit down to study and put on video game music, you know, like Halo and stuff like that, so that he would have just this sort of background driving, active, you know, do stuff music. And apparently, like psychologically, that fits really, really well with, you know, the act of studying. I'm gonna di.fm, probably gonna have to mute the tab or something. Is this gonna immediately start playing stuff? No, good, okay. I'm gonna leave that up. Take a look at that later. All right, what else do we got? Twitch is going strong. There's 44 minutes to an ad break. I need to put the ad break light back up. We don't really need this. These are fascinating. I don't know if we'll need it or not. I'll leave them up. I'll leave this up. These are from yesterday, and there's the GitHub with all of our information on it. And here are more parts that we looked up. I don't know if we'll need to look these up again. This is stuff that I need to order. I don't know how serious Julian was about me getting him a Steve's MS-22. This build is nothing to sneeze at, but I am going to have enough extra parts to probably build 2 of these. So maybe I should just get one for Julian, just bite the bullet on that one. Apparently it's a pretty cool little filter, so yeah, maybe I'll order one for him. It's a $40 board. He's going to have to buy me many sandwiches to make up for that. Many sandwiches. How much is one of these, like, assembled? $300! Oh, hey! 250 bucks. Woof. Yikes. Oh, it's this song. This song was in everything. Dun, 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 dun. This is in everything. It was in ads. It was like every like DJ night kind of thing. Like at your modern rock radio station DJ night would be playing this song. Couldn't get away from it. It's very noisy. I do not know how to deploy these. I tried peeling the corner. Oh my God, this is so distracting. I don't have an account for anything, so I can't fast forward it. Boom, 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 boom. I mean, okay, so here's what we've got. I have these little tiny pieces of copper trace that I could use to repair stuff. I don't think it's going to be a good candidate for putting this 10K resistor in between these 2 points. I was thinking about using it because I could come out and get to the resistor and then I could go up and over. But that has the same problem as just the floating resistor. So I think I'm just going to put a wire up and over, and then I'll put a wire down and over, and we'll be done with that, right? But I was going to try to use these little trace repair things because they seem fascinating to me. They should work well, I think. The problem is we've got our wax backing on the adhesive material, and then we have some kind of a front material that's obviously not, it's just plastic, right? And it's just there to like protect these things from being rubbed against. The problem is the adhesion to this front piece is too strong. And when I try to peel it away, that looked like it almost got it. When I try to peel the front away, it's peeling the adhesive backing from everything. I'm not even sure the adhesive backing is temperature stable. So if I try to get to this, yeah, I just ran and grabbed them. Oh, I got it. Oh, no. There he is. Okay, so that's step 1. That was very difficult to do the first time. Dun, 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 dun. So this is the hard part, is actually getting... I'll use some sharper tweezers. This thing was like $9, so I kind of want it to work. Maybe these will be a little better. Oh, no. They're going to take a little getting used to, I think. What else do we have? I've got much better tweezers in here. I got to get rid of some of these. Let's go somewhere else. Don't need the big ceramic ones. They're too clunky. These are a little clunky too, but they serve a different purpose. I heard someone in a parking lot yell, "Get bent," to another driver. Depreciated insult. I don't know if I use it as an insult anymore. I do still use "get bent." All right, so that could do that. Now, let's just pretend we're putting it on Momo. Now, getting it to apply in the right place is going to be... Uncle is not a good one. I don't like Unk. I am an Unk, so whatever. I'm not going to be like the Karens saying that it's like, you know, the worst insult ever devised. Unk is like 9/11 times a million. Like, no, it's not. I'm not going to do that. So the difficulty with these little trace things, I think they'd only be good if something like, yeah, that's, so this, I would have to like sneak it under something. I'm not going to be putting a resistor in the middle of the board with this. It's even hard to just get off of here. Gimme. Oh my God, it's just, I've lost control. I've lost control. I'm going to put it in with its buddy over here. These will be totally useless until they are very, very, very useful indeed. Very useful. But up until then, they are a total waste of $9. So I'm going to leave the one without the cover on it. Put that in there. And this one, I guess, got its own thing. It's the size of the whole package, but we'll just put them all together like this. I've been told size doesn't matter. But that is tiny. It is very small stuff. You gotta be a little dexterous. Or have good magnification and a wrist rest. Just like welding, it's all about your comfort in order to perform these very, very tiny tasks. But okay, so that would be useful if, for instance, I was reworking like this and one of the traces decided to come up with it, leaving me to devise some kind of a pad fix under the chip, because then, although it would be nigh on impossible for me to actually work with for like the RP2040, I don't really think I'd be able to do it. I might. You'd expose a little bit of the trace further down, and then you use that repair trace to get you to that location and solder to it, but not to fake that it's an actual like pad. It's just like a, and then you'd put a little dollop of UV glue on top of it to hold it down. But I don't think it would really work that well for anything else. Like these pins. Or something with, yeah, like these. If some of these lifted when you're replacing the chip, those would be good candidates for repairing it, because a big piece of wire would be enormous. But let's get start soon out of here. I want to get to work. This is a good mix. I didn't discover the fourth, or no, volume X. I guess it's the 10th, my definition of chill volume. Anyway, lawnmower, computer brain, everything we did yesterday, I'm redoing. I'm not going to resolder. I'm just, the resistor that we added in was on the wrong points, and I discovered that because my friend linked me to it hours and hours ago, and I finally clicked into it at the very end of the stream and was like, oh no. Yeah. Oh, I don't have the image up anymore. Oh, cool. Anyway, the image was basically just where the resistor was, and we put it in the wrong place. The 10K resistor is a result of minor flow of like order of operations things. We've got 100, so this is another 10K, so I don't know what that other 10K, it's going to somewhere else, but we're trying to intercept before the inrush gets here, so we're adding a 10K and we're putting it up to this. I don't quite know what the heck's going on here. It's very strange. I missed yesterday. Oh, if you missed yesterday, what we're doing is we are working on Momo. Momo is my friend's robot vacuum cleaner. It didn't start as a robot vacuum cleaner, to my knowledge, or at least, was it an RC vac? I think it was still a robot vacuum cleaner. It just was, Momo had a different brain. we don't like to talk about it. So Momo is also a cowboy. Momo's wearing a little cowboy hat. See that in his little eyes. So anyway, that's the cover for Momo. This is the base, and the base is essentially a 2-motor robot, one of these things that has casters on the front, and then it steers via differential between 2 gearboxes that have individual motors. So we got a motor on the left, motor on the right, and then a motor in the middle that has this sort of plastic spinny thing on it with like little friggin' like razor blades that cut your lawn. And so Momo can be left to their task, and they will mow the whole yard. Did I say vacuum again? Did I say vacuum? I might have said vacuum. Momo is a lawnmower, and I keep mistasking. It's like kind of like misgendering, but for some reason I can't get it into my stupid brain that Momo is a lawnmower and not a vacuum. I will say it. I really should have a counter up on screen for how many times I accidentally say vacuum. But anyway, robot mower, open source brain. That is a large vacuum. That would be an appropriate size yard vacuum if you're like my friend's parents and do things like vacuum the woods. My friend caught his dad out in the woods vacuuming. I can't explain it. Anyway, so here we go. Momo, hooray, big battery. The problem is I can make 28 volts over here. It's just that the battery interface was just a little bit confusing. It requires like that the switch bridge 2 contacts, and then power goes into one and the others are always powered, and I'm just like, you know what? Let's just plug it back into the battery to do the troubleshooting. Where are we? I need to finish this 1 resistor soldering. It's some kind of an inrush thing due to the charging circuit, and it fixes it. It fixes it very well. So I'm going to do exactly the same thing. Maybe this vacuuming at least. That uses the real-time clock. I see. So the clock inside of here is probably all discombobulated right now. I don't think that's a big deal. It's not really going to connect to anything. What happened to Momo is that through the cycle of life of a yard tool and a robot, all kinds of little things were modified and changed, and then heat sinks were applied to the MOSFETs, and then the MOSFETs blew up. And I don't blame anybody for that kind of behavior, because I do the exact same thing. I put heat sinks on MOSFETs. It's what I do. I have all kinds of. There's a heat sink right here. It's just right here. It's just in my blood. You know? So yeah, FETs explode. That's the second thing that they do. The first thing that they do is switch incredible amounts of current very easily. The second thing they do is blow up. So it's right in there. It's in the data sheet. It's like the second bullet point. I did amp repair for a short amount of my life. It's always the MOSFETs. Yes. I agree with that completely. We will clean off the desk in just a minute here and get Momo up on the desk. I'm not going to plug the motors back in for testing, although I have a feeling the motor leads just go to these. So there's nothing plugged in there. The FET board is designed to within an inch of its own specifications. It's a little bit too tightly spec'd. And so things like, well, I mean, the heatsink didn't blow it up. It was maybe a short through the heatsink, but little bits of overcurrenting and, you know, wear and tear and time and stress. When you spec something so tightly, you're kind of stressing out all the components. And so it was bound to fail, and it did. And so now here we are trying to knock something off of my friend's to-do list by putting different motor drivers on it. We could do surgery to the motor controllers, but I feel like that's just kicking the can up the road. If there is a possibility that we can get the open robot, open mower, whatever, to talk to new cheapo China CAN bus capable motor controllers that my friend has in his possession right now, I think that would be more beneficial. So I think what we're going to end up doing is looking in the data sheet. Well, first of all, we've got to vet out that this thing is okay. When a component like that blows up, you never know what cascaded into the failure. So the first thing we're going to do, and from the reports of my friend, the Raspberry Pi will power up like this, right? This will power up. So we're going to affect, I'm doing a little bit of an oh bother special and kind of butting in on my friend's project here and making it like super neat and organized. So I'm coming in and I'm soldering a surface mount 10K resistor in here to do that little power supply repair, and then maybe we'll put a dollop of UV epoxy on it so it's like professional and it doesn't fail ever again. Because when we open this thing up, that resistor was not connected to, it was only connected to one part, and it was a through-hole resistor. I'm debating about whether or not I go back on the whole through-hole versus surface mount in this application, because the surface mount resistor is just going to be sitting on the board with a wire on each side. That's the same thing that the through-hole resistor would be doing. So maybe I should get a through-hole and put it in there. I don't know. Well, I think I'm going to do it with my little wires yes, it is a surprise stream. A surprise stream on my scheduled time, on my scheduled day that's in the schedule. Surprise. Anyway, so I'm going to do the repair, and then we're going to power up Momo on Momo's battery. It should power as is. With the motor controllers in there, it didn't power. I'm not surprised. The motor controllers, MOSFETs be damned. I don't have attention span to read schedules. Then you're not allowed to be surprised. It's not to be described as a surprise. Anyway, so we verify that the right voltages are in there, because when a component fails, it may cascade a fail to other things, and so it's possible that we would have a voltage we don't want on the motor controllers. So we'll test that and make sure it's okay to put components back in. We have a GPS board that we want to make sure also is getting an appropriate amount of voltage. Then we want to take a look at this Raspberry Pi trying to communicate with its buddies around here, and make sure that the Raspberry Pi's I/O wasn't befouled by whatever the hell took out the MOSFETs. A picture of my friend right here. Whatever came to foul in the MOSFETs and blew up Momo, we want to make sure that the other parts of Momo's brain work properly and can communicate with a new driver. So once we verify that, take a look at all the stuff. Yeah, it's an RP2040 and a Raspberry Pi. It's a little weird, because the Pi can do I/O, but maybe they needed really fast I/O. And so these are just like communicating with each other. It's strange. And it's not the only RP2040 in Momo. The front panel controls have its own RP2040 as well. We're just getting crazy with these $1 microcontrollers. $5? I think they're $5 now. Okay, anyway, so once we verify the voltages are okay, then we can verify that the appropriate communications are going on. Then we can build a board that fits in on all three of these microcontroller slots and has connectors that will connect to the new speed controller for the motors, right? And at that point, Momo's off the healing bench, and I kick it back over to my friend, and we'll see what happens from there. So we're trying to get there this stream. We're a little bit more focused. We sort of know what we're doing. We've taken a once over on all this stuff. We know everybody's functioning. We're going to plug it back into the base, and then we're going to probe around with the oscilloscope and see what kind of stuff is going on. First, though, I need to do this little piece right here that I ruined. That was working perfectly from my friend. Actually, it broke off a little bit, but I just don't like a big through hole around all these surface mount. And unfortunately, I cannot come up with a clever way to locate this 10 kilo ohm. It's funny because there's two 10Ks. One of them comes off the side. This directly connects. And for some reason, we're adding a 10K to that. So I don't know. That seems invalid to me. It seems invalid to me. Okay, well, MS Paint, which I've already got open, but this is a different project. Oh, we can write on it. So basically what we're talking about is we've got like a transistor, right? So I've got a transistor here doing transistor things. Who the hell knows what it's doing, right? It's who knows, doing stuff. And then we have our line coming in here, going directly into the transistor, some kind of a 10K resistor here in the path, but that would be taking very little current from our transistor. So instead, what we do is we add a 10K here. This doesn't make any sense to me, because your inrush is just going to go straight through. It would split off like a little tiny portion of the current, just a little tiny little like nibble of current. I kind of want to look up like where this suggestion is. And according to this thing, we have open mower 0.13. So let's look up open mower 0.13. Basically, okay, yeah, let's, here, my friend has an explanation. Vmax of Q6, that would be this one over here. That's Q6, right? Hold on, let me double check. Double check. Q6 is the big boy. So Vmax of Q6. Hold on, I just clicked on my chat thing. All right, there. Oh yeah, I need to start up YouTube chat. Sorry, YouTubers. Are you guys started up? You're not started up. Let's start you up real quick. I know it's the discombobulation of streaming is a thing. So just give me one. I'm restarting the chat thing so that it finds YouTube. There we go. Okay, now we have YouTube. Hey, Madam, how's it going? Okay. Vmax of Q6, which is the big boy. It's 20 volts. The little transistor sometimes shoots above 28 volts. Normally it's fine, but most of the time, or sorry, normally it's fine most of the time, but more recently, because of hot weather, it's not. 10K resistor makes sure that Vmax never exceeds 20 volts on the gate Q6. Oh. So keeps Vmax below 26. The way I would do that is with a Zener diode, but that's, I guess, for another day. That's something that we do in the modular synthesizers all the time, is you have a diode current limiting. What's up, Amazon? Neon Walrus? I'll say the whole thing. Do I even have ones that go up to that voltage, though? That's my question. Hold on, I want to see if I could put an ancient Zener diode in here. Oh, the resistor is way easier than the Zener. Yeah, most people don't have... That R40 is really bugging me, but I'm not going to touch it. It just really... It really bugs me. Ooh. Okay, anyway. I have this wonderful system, and I wish this was with all of my stuff. The 0805s probably wouldn't fit very well. The resistors probably wouldn't fit very well, but these China sample books are awesome. Awesome. 12 volts, 22. So I could put... That's 9 volt. Why did it drop down to 9 volts again? ZMM, I don't know what that is. So yeah, I could put a 24 volt Zener on there to, yeah. But just putting a resistor on there solves the problem, and it only costs a resistor. Yes, Zener and the art of motorcycle repair. Zener diode and the art of Momo. Well, howdy, I'm Momo. Y'all need a lawn to be mowed? Well, I'm gonna giddy up on it. All right, let's keep it a resistor. Yeah, I'm gonna keep it with what worked. Yep. If you had time, you would have. Yeah, I totally understand. Like, you were trying to get your lawn mowed. Like, it's like, yeah, time to do something like I'm doing, and I got a microscope and all these tools. Yeah, we're gonna do a nice clean resistor, and then I will epoxy it down so that it's a permafix, and then it's just NBD. I just wouldn't have been able to leave it in your tutelage without doing this repair. I'm gonna maybe get a little piece of circuit board. There's my old GeForce 4. Actually, I think Big John is the only person alive who may have seen the GeForce 4 actually work before I tore it apart in order to make myself a little FR4 surface. That old GeForce 4. Actually, he might not have. I gave this to a friend of mine because we thought Star Citizen would be out within the last 10 years. You know of that? I don't even remember it. What computer did it come from? I'm gonna get wire wrap wire. And the water cooling. You should have seen, my current computer is water cooled, but it's actually really annoying. It's really quite annoying because bubbles keep escaping somehow. And you know, I'm using larger ropes to tie bubbles up, but he just keeps getting out. No, the thing is like producing bubbles, and they get into the just everything. It's a hassle. I need to redesign it. I was thinking of doing like a water cool repair day and trying to put the computer back up onto the frame rails. I used MakerBeam and some 3D prints and then a bunch of hexagonal grids. I've got some hexagonal gridding that looks really cool and techy. And it made a really, the best, my favorite combination of materials is from that computer project. And the materials are red, translucent red PETG through the 3D printer. So that makes this deep red plastic. Black hexagonal grid grating, silver countersunk screws into the red, light anodized frame rail, and then matte carbon fiber. That combo of colors and materials is so cool. Water cooling and being a hassle? No, surely not. Surely not. No. Yeah, you know what? Everybody warns you that it's going to be a hassle, and then you're like, it's a hassle. And they go, I told you so. I told you it was going to be a hassle. And I'm like, yeah. What are we doing here? Like, I know. That's what I signed up for. And it's never like a predictable hassle. It's always a hassle in like a wholly unique way. I'm trying to get you to solder here, bud. Yeah, computers in general are crap. I would love to convert, and unfortunately the Gabe Cube ended up being a little too expensive for me to do that, even though I, you know, probably by all means should have the budget. But Gabe Cube ended up being a little bit expensive. But what I wanted to do was get 2 Gabe Cubes and just completely move over to Linux and have one do OBS and stream, and then the other one would have been a work computer, and just not bother with specifications anymore. Just be free of the whole system. It's like, I feel free. I can finally breathe. I don't have to have the best computer. That is kind of what I did with my previous build, though. I kind of just bought stuff that would work for like 7 years and just move on from there. I need to hold down the resistor. It's walking around on me a little too much. This is sort of a weird application. Good old Captain tape. Top of the morning, Captain. Iron's too big. Everything's too big. Everything's too small. Get a little bit of that flux on there. Clean the iron tip. I should have pre-tinned this, and I think I did. We'll go over that again when it's actually got something to anchor to. And then take that to that side. Actually, this one, yeah, this goes to this side. It's called Captain tape, and it is a particular material. It's a something EMI'd. What is that called again, guys? Somebody knows in chat. But it is a, I guess, a plastic that is very highly temperature resistant. K with the Captone is a 3M product. Yeah, and it's a very high temperature tape. It's very light. It does not leave a residue. And so the two, well, we don't use it for its lightness. NASA uses it for its lightness. They wrap wiring harnesses in it on things like the moon lander. Some pictures of the moon lander, you'll notice that there's sort of a yellow tape that's holding things together, and that's what that is. Because it's very highly temperature stable, it sticks pretty nicely, it doesn't leave a residue. That's obviously not why what NASA uses, why we use it. Polyamide, there we go. Polyamide. And the problem with Captain tape is that whatever adhesive they use is so good, I wish I could get that on clads of copper sheeting. It seems like you can't. And people have tried to link me to what they think is the answer to my never-ending quest to find a copper-coated Captain tape. It doesn't even need to be Captain. It could just be copper-coated with the same adhesive that's on the backing of Captain tape. Because it sticks nicely, doesn't leave a residue, it stays in place. I could affect all kinds of circuit board repair with something like that. But we use it in the lab because it's temperature stable. It can go through a soldering oven. You can hit it with a soldering iron. You can drop stuff on it, et cetera, et cetera. It insulates. So sometimes we use it to insulate different components from one another. It is just all around, it's good. It's not, you don't really leave it in permanent installments, but for prototyping and stuff like that, it's very useful. Copper paint. You can't really solder to that though. See, the problem is the copper tape that they use for like stained glass windows. I've used that before to lay traces down on a circuit board. Like for instance, what we want to do with Momo right now, if I had that kind of tape, the Captain backed, that high temperature, Captain tape, if you put the iron on top of it, the adhesive doesn't melt and end up having everything slide around. Whereas those copper clad for like stained glass windows, they will slide around when that adhesive gets any temperature at all into it. And it's very, very frustrating to work with. So if I found it doesn't need to be polyamide, it's whatever adhesive they use on polyamide tape. I need that for copper cladding, and then I can lay down a piece of copper, cut it with a knife, peel away the excess, and I've got a trace sitting on the circuit board. That's not adhesed like as well as the copper substrate, but it is still very well attached. If you could get, yeah, and there's like trace repair tape, but it's super expensive. I need it to be the same price as polyamide tape. That's sort of the limiting thing. I don't know, people just don't look for it. I guess they wouldn't find it useful or something. I think it sounds incredibly useful. So when I solder this one, the resistor itself, the connection to the resistor itself is probably also going to melt. So I need the whole thing to be kind of suspended in place. I'm not going to glue it yet. Oh, did that just fall off? You son of a bitch. All right, whatever. Whatever. I'm going to do, look, I'm doing do the repair. It's fine. We're going to do it. I may end up using a through-hole resistor, to be honest. TBH. Bum 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 bum. Dun 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 dun. I think I want it to be above. Let's go above. Womp 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 womp. Dun 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 dun. Mr. Oizo flat beat stuck in my brain, stuck in my brain and stuck in my brain. Okay, that's not. Is that no? It's still not soldered. That's why I used it in the first place. Yeah. Yeah, it seems like it might be a little easier for me just to bend the leads on a surface mount or on a through hole. Let's do that. Let's do that. Let me stop being so pretentious in my ability to let things go, ability to not let things go and have to do everything the special bother way. Let's throw a regular resistor at this shit. It's all shit. No, it's fine. It's fine. Let's just go with easy. Easy does it. I thought that the repair was a little different, and I thought it was between different leads. And if it was between the different leads, it would have been a very clean little solder job just to have the 10K go right between these two leads, but that's not what it is. It's between this and this, and so it's kind of important where it is. So I'm going to get a 10K through hole, but it'll be a precision 10K through hole. We can be a little pretentious still. Just a little, right? Just a little. I will get my butt out of my own ass. 4.7K. What are you? I think these are the 10Ks. They've just been picked through with all the synthesizer projects. It's just this giant... Okay, hold on. Let's go back to here. $100K. No, don't. All the synthesizer mixing things use 100Ks. This is so normally a repair like this would definitely not take me this much time, but I'm streaming it. I'm you know, farming it for content just because it's fun and we're having fun doing it. And that means that I am doing a lot of like explaining myself and oh, now we're doing this and now we're doing that. You know, that takes more time. Streaming it is not a quick way to do these things. What are these? Are these 10Ks? I never got a read on these. 4.7s. Where are my 10s? Don't tell me I don't have a 10K. This is probably 10. Let's check. This thing 2 ohms. How are my ohmies today? Did you guys get it? Because it's like ohms. It's like ohmies. It sounds like homies, but I'm actually just saying this is the electrical term. I've heard every existing version of ohm pun. 430 ohms? What am I doing here? That is not what I'm looking for. Where's 10K? I thought I had a big bolt of 10Ks. These are just so disorganized. Definitely got a 10K. That is a... Oh, this is a 10K. All right, there we go. Cool. 10K on the clock. Bonk. This sucks. I need a better way to organize these. Ma, it's that fucking cat again. All right, so now we get to here. And what I'll do is lay this puppy down right here. And so we'll bend down and over on both leads. So we go, take the tweezers. Where are my tweezies? Tweezy Jeezies. Hold on, let's get my Twizzlers. Right here. Both leads bend down at the distance of the tweezers. Here, you guys got a better view of this from here. Just like that. And then this one, same thing. And then we almost immediately have to flatten out at the base. So I'm going to need a different distance here. Let's see, these tweezers will probably do it. Hi, what are you doing? It takes a little bit to explain, but this is the brain of a robot mower. Sorry, it takes me a little bit to say because every single time I try to say it, I have to fight my brain telling me to say vacuum cleaner, robot vacuum cleaner, robot vacuum cleaner, robot vacuum cleaner. It's a robot mower. It's not a vacuum cleaner. I just have some kind of like a Manchurian candidate mental block that does not allow me to say these things. So anyway, what I'm doing right now is I'm bending a little resistor so that it fits flush to the board, and I can glue it down with epoxy, with ultraviolet epoxy, which comes up clean. If you pry it a little bit, it'll pop off. But what that'll do is that'll make this a little bit more resistant to vibration, which is experienced in a product like a robot lawnmower. We are trying to fix Momo's brain. Momo is a cowboy, Momo is a robot, and Momo is also a lawnmower. And so in enabling Momo to do their job, wrangling grass leaves, see that's too, made it too big, that's too big. This resistor should sit flush. So what I'm trying to do right to now is set up this little inrush limiting resistor And then we're going to power Momo up. And when we power Momo up, we can see if Momo can accept new motor controllers. Those new motor controllers are going to be very much unlike the other ones that it had because they have not exploded yet. The exploded ones are a little bit too tightly spec'd. Seems to be kind of a running theme here in the DIY open source world is the specifications on Momo's parts were a little too tight. And as such, subject to the real world, which will push your numbers in every direction. And in doing so, Momo immediately folds. So we just need to work with that information. I think that's a little closer. And do right by Momo. What would Momo do? I'd mow the grass. Oh yeah, this is what Momo would do. Howdy. Okay, so I'm doing a little, this is just me being fancy. I can't not be fancy. I have to be fancy about it. So standing up a through-hole resistor, it's still going to stand up pretty far, isn't it? And I've also done those too far out. All right, trying again. Why don't you just solder it in? Well, then it's not going to be cool. It has to be cool. It has to look cool. And when somebody sees it, nobody's going to see it. But if somebody sees it, they go, wow, this is really cool. Whoa, cool job. I have to. I must. So yeah, we're repairing a robot lawnmower. Robot roll call. Cambot. Tom Servo. Crow. It seems like I can just... Yeah, it seems like I can just go direct. I don't have to do my little drop-down thing. We can just go like that. And I can cut these short. In the not-too-distant future, next Thursday AD. It's already the right distance. Just this one needs to be super short. Is Momo smarter than a robot vacuum cleaner? It has a Raspberry Pi 4. It has an RP2040, 2 of them. Yeah, I think it is. I think it actually is. This better look marvelous. It's not. I'm trying. I'm trying, man. If I do that, and I got that, and there's a little flat piece. And this one, I'm gonna do one of these. That's a little flat thing, and then I need to flatten them both so they're flat on the board. Ugh. Hold on, try not to mess this up. Bum bum ba-dum bum. Dun 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 dun. There we go. Okay, that might do it. Trying to look at where we're actually putting this resistor in. I think I like the surface mount one better, but I gotta just live with my choices here. Okay, so my impression of how long these leads are is way overstated. They need to be like super short. I'm gonna waffle around at this for like an hour. I really just need to get it done. This is just me being fancy. I said it before, say it again. I'm just being fancy. Yeah, it's like my bend is here. It needs to be way earlier in the thing. I could just live with it like this. Although those Roombas, I mean, they map your whole house, right? Where does that put us on the map in terms of intelligence if it's mapping my whole shit so that Skynet can come in with a drone and kill me after they spot me on all the flock cameras? Okay, I can't solder on that surface. Everything's fighting me. Well, it's probably because I've got too many like loose. I'm relying on the loose components to stay still, and I got to be careful about that. Get off! Jeez. Back over here. Fortunately, we don't have to do this in the middle of a grassy field with bugs and stuff. So I can be fancy. That just spun on me, and I really, this is why I dislike through-hole. I don't know if you guys know that. I dislike through-hole electronics quite a lot, actually. Surface mount is so clean. So clean. Oh, it's like totally... Is this upside down? What's going on here? Wait a minute. No, this is the right side. Cohabitating with the components here. Okay, it's just sitting on top, it's floating over top of it. Okay, there we go, like that. That's what I need, right there. Are you kidding me? What's going on here? The tweezers are holding it further away, and that's still too long over there. I can kind of bend it away, though. And then this is not like soldering because it's so much thermal mass on this pin. Is my iron on? Yeah, iron's still on. Okay. What? Walk like a resistor. I have a feeling something's sticking up into the air, but oh, that's as close as I can really get it right now. So let's just take this lead and make it go over just a tiny bit. Come on. There we go. That's what I wanted. All right. So now I can just solder this down here. We'll take a look at what it looks like from the side. I'll clean up that solder a little bit. Now that I've got the lead on there and it's sort of stuck in place. And that looks like a little bit of a dry joint. Not quite. I think it's okay. Willing to let that slide. If I can clean up a little bit of solder. So I'm just going to hit them both with a tiny little bit of tacky flux. That tacky flux is going to flow out over everything and make my solder look so much nicer than it does right now. Stinky. Uh-oh, stinky. Feels like that's sticking up too much. Ugh, all right, I'm not touching that. It's like too much manipulation. What the? Was you not soldered or something? What's going on with that? What the hell was that? It just like, I guess there's so much thermal mass there that it wasn't letting go. It was still molten. And when I hit the other pin, it just like moved. So I gotta wait a second for you to solidify. It's not moving, okay. And now I can bend this end into place. Is it not moving? No, because it's too close, I see. All right. See, the problem is the solder isn't molten, and I want it to pretty much cohabitate where the solder is instead of doing like a bridge. So that's that. So yeah, that's so much better looking. And then when I heat that up, that's going to move a little bit. I want this to lay down flat in front of the pin, but I don't think I can. Beggars and choosers, you know? Yeah, that's as good as it's going to get. Okay, there. Okay, so there's the 10K. We've installed it. I don't think I'm going to do... I should put a little dollop of thermal epoxy, or not thermal epoxy. You should put a little dollop of ultraviolet epoxy on it to keep it in place. But I think this is good because it's kind of pushed up against this. I don't think it's really going to vibrate itself anywhere anytime soon. We've got a righteous blob of solder that looks like it's not cold welded. It's completely wrapped around the pin on both ends, so that should hold up pretty darn well. So there's my contribution. I've replaced the regular resistor with a precision one with smaller leads, and it's soldered in flush to the component. And so now our inrush is limited in some capacity that I don't understand because it's a weird fix, but that should be good to go. Now, Momo is ready for power. Momo should probably not let its power go to its head. Momo is a cruel and unmerciful god. But we're going to give Momo power, so I need to make room for a giant robot lawnmower on my desk, which means moving a couple of these things away. This stuff goes in the garbage. Oh boy, that's going to go everywhere if I don't hit that garbage. You know what? I'm going to put this somewhere else. If I throw it in the garbage right now, it's going to bounce off of the top thing in the garbage and send little bits of sharp plastic all over the shop, and I just can't have that. I just can't. Better to look marvelous than to feel marvelous. I guess. All right, multimeter, we're probably going to need you back in a minute, but we'll just put you aside for now. These are Momo's other wires. Just keep these over here. They're labeled and numbered. Placard goes back here. Big piece of beefy steel with little circuit board holders, so they can go somewhere else. I don't know where to keep this thing in the interim. Yeah. Geez, that is a heavy piece of steel. I could use a slightly lighter piece of steel for that, I think. Oh, what is this tape doing here? Put that away. It's going to make a little space so that Momo doesn't push all of the crap on my desk off of my desk. And then, let's see. This is back there. Doing okay. We're doing okay. Screws and stuff. Need to go with the screws and stuff. Oh, but there's already a lot of screws and stuff. Where the screws and stuff go? No. It's just going down here. Or well, maybe right there. Okay. Just trying to make a little space here. Okay. All right, let's bring in Momo. Momo barely fits on the desk. Barely. But this is basically remote control, or I guess some kind of a programmable robot, technically vacuum cleaner, but the Open Mower project has added to it and enabled things like GPS and other sensors. Don't have room for my mouse. Let's get both of your wheels on. Okay, you got these knobbly wheels too. They're kind of awesome. Okay, so when we found Momo, most of the stuff was plugged in and it was just sort of put right on the circuit board. There's a lot of stuff that I'm not going to plug back in. A lot of the sensors and stuff that we don't need for just a simple test. So I think in that vein, I think I'm just going to do the battery connector, which is this one right here, that's hooked up to the power switch. Yeah, and leave the motors off. I don't know what this one is. This looks like it's probably the GPS or something. And there was a USB that was plugged in. I don't know if I need to plug in that USB. Probably not. And then we'll look at heat on the board first, see if anything immediately heats up. I think the main thing is that we're just going to be poking it for voltages. And we found 24 volts on the battery. We're going to look at the voltage regulator, which has these nice big chunky test points that we can use. Just make sure all our wires are in the right spots. It's a mess in here, but as to be expected for retrofitting a... Actually, I probably should plug this one in because I'm not going to be able to get to it. And then I don't think the antenna plugs in until the GPS plugs in. So this is bugging me. It's bugging me. You get out of there. Yep. Man, I'm so tempted to wrap up these wires in some spiral wrap. It's a bad thing to do when you're troubleshooting something, because then you're like, oh, this is broken, and you have to like get it out of the spiral wrap. Keep that down there. There we go. Okay. My compulsion to make things like neat and tidy is not good. It's not good. All right, 2 screw holes there, and there's the other ones right there. Yeah. Let's just get those in so that this thing is stable. Welcome back. So yeah, I let go of my ego and I put a through hole in here, and it's hugging that FET really tightly, so I don't think it'll vibrate at all, presumably. Much unlike its buddy that was floating in air. But yeah, that should cinch that away. So okay, there's Momo. I've got the USB plugged in. Oh no, I don't. When did that unplug? I thought I plugged it in. Wait a second. I'm going crazy. Okay, well, the USB's over here. I'm not plugging it back in. I don't think it's going to need that for a power check. I'm finding lots of copper tape on Amazon. Yeah, but notice how they all say that they have conductive adhesive, that it'll conduct through the adhesive, so you can put it on like the outside of something and tape up your enclosure. You don't need it. Okay, cool. You can put it on your enclosure in order to, block RF. All that stuff that's claimed under the tape, that means that it's using the same adhesive that I see on all of the copper tape, which is not the stuff that Captain Tape has. Captain Tape's adhesive can withstand high temperatures. They use it in powder coating. They use it in all kinds of other high temperature applications. They send it into space. I need whatever the adhesive is on Captain Tape on copper tape. I don't need, but I mean, it would be nice, because then I could make my own traces. And it's tough to find. And whenever I explain this, there's somebody in chat who goes, I found it, it's this. And I'm like, no. That uses the conductive adhesive, which means it's not, if you look at the temperature stability, when things get to be like 85 degrees, that tape turns into soup. It's the biggest thing that pisses me off about electrical tape and other kinds of tape. Oh, it's 3D printed. And other kinds of tapes is that people claim that they'll do all kinds of stuff, but then they don't look at the temperature stability. And so if you use electrical tape on your electrical projects, you will end up with something the consistency of, something the consistency of soup when it gets into contact with the real world. And I know because I've done this. I have done this many times. Let's sneak the power cable under there. The temptation to spiral wrap every single link in this is so huge. Just so it's all just big wraps of wires. I'm not going to do it. I'm not going to do it. It's better this way, and I'm troubleshooting. All right, so this is live. So I'm going to be careful. Make sure that these probably distorted a little bit. No, it fits nicely. There, okay. So Momo has power but is not turned on. Let's get the multimeter out. I probably need one of these newer fangled multimeters, because that way I could probably get the number from the multimeter wirelessly. Yeah, it can become a big A big ball of nope. Big ball of no thanks. I don't want that all over my hands. A good Saturday night. Wait a minute. No. You guys, nope. Okay. Voltage. So, according to the pinout, oh God, I can't even operate my own computer. Momo, why are you so fat? Let's get this out of here. You go away. You are very cool. We'll look at you later. Okay, so this connector, pins 1, 3, 7. This is so weird. F4 goes to the fuse. So if we go from pin 2 to anything else, so let's see, pin 2. My mouse. I shouldn't use the mouse. I should use these. There we go. Pin. Which fucking pin is 1? Is this 1? Which one is pin 1? You've got them labeled. Wait a minute. No, that's J2. And there's a little linky poo here for the thing. I don't know how Molex labels themselves. According to this thing, though, well, that one's not connected. That's pin 4. Pin 6. I know where to turn it on. I'm checking this before I turn it on. 3, 4, 5, 6. So is it 1, 2, 3, 4, 5, 6. 4 should not be populated. 4 is populated on this connector. This is the wrong connector. This is J2. Connector 204, top, bottom. Pins 4 and 6. This is open mower version 0.13.2. 0.13.2. It's a custom board that I think is meant for this hardware and other hardware, but it is retrofit and it is an open source project onto a mower that I think otherwise was robotic but was not open source. What's up, Lines and Squares? How you doing? It's not on, but there's still power flowing into the connector. This is a connector to a battery. Now the one white wire is not connected, and then the bridge between two of the connectors are not connected, but we still can get 24 volts on this. I'm assuming the black wire is ground. And if we go to something like red, we get 24 volts. And it doesn't use RTK GPS. What's the difference? What's the it's just a particular GLONASS. I should know this. I did tracking devices for the FBI for 5 years, 2 years. And yet somehow I'm like, what does that mean? Oh, GPS, what's that? Haha, haha, what's GPS? Haha, smile. Fucking used the server that all their tracking devices connect to. Haha, what's GPS? Haha. all their emergency trackers. Haha, what is a computer? Haha. All right, let's turn Momo on. Are you guys ready? We're going to watch the thermal camera and we're going to make sure that nothing suddenly cascades and heats up way too much and then explodes. I don't think we're in danger of that because we've already got 24 volts running to this. It's just not being used anywhere. We are now switching it down so that it flows out to everything that it needs to go to. Like if I check the in here, they've got these wonderful vias, big vias that I can use to test whether or not power's flowing to stuff. It's big in and out. So let's check. Let's power up. 3, 2, 1, go. Oh my God, that's fucking ow. My eyes. Jesus. 24 volts going in. Where's my... There's out minus. Where the hell's out plus? 5 volts. So we have a brutal amount. We've got like 6 amps of 5 volts coming out of this thing. And this is not an oscilloscope, but it is reading pretty stably. Look at those sick wheels. Yeah, they're making marks all over my hands. Cute puppy. What do you think about that, Momo? They think you're cute. Raspberry Pi's power is on. We don't have any drama lights coming on. It's going to be trying to connect to my friend's Wi-Fi. It will not be able to. That's fine. Yeah, these are slightly rubbery. I have a bolt of TPU that I need to like print with, and I've not messed with it yet. I should play with this stuff. I don't have like a lot of grippy handles that I'm making, you know? My dildos are far more advanced than that. That white LED sucks. That's like pain. Okay, so Pico is fine. Raspberry Pi is fine, which, like, man, Raspberry Pi is like a canary in a coal mine, man. This thing will just go, you know what? I'm gonna die, and then it's dead. So that seems okay. This guy right here is warm. Not detrimentally, it's just warm in operation, I suppose. Yeah, those are fine. You know, the reason OctoJ pushed to get me the thermal imager was so that I would not poke electronics with my finger to test whether or not it would burn me. I have not learned anything. Does the puppy have radar? What sensors does it have, Big John? I know right now none, because nothing is plugged in, but this thing, you can plug in big whiskers on it, and it'll do bump sensing. This is not a LiDAR. This is simply just to raise and lower the mower floor. It has the good GPS, and it has Wi-Fi from the Raspberry Pi. I think that's about it. Oh, and then actually on the control panel is one of my favorite sensors. There is an upward-facing cup on the back of that, behind his little cowboy hat. Way back there's a little cup, and it's got 2 electrodes in it, and that's a rain sensor. The cup will collect water, and then it'll read a difference in capacitance between those 2 pins. I think that's very clever. Okay, so far, I'm not seeing anything particularly wrong. The Pico Pi is, of course, heating up as it normally does. That actually, ow, that's kind of really hot to the touch. Yeah, that gets hot, though. That's, and then Pico Pi, that's not burning me, so everything seems to be honky-dory. So the next thing that I want to do, I'm going to turn off Momo for a minute here. Not that I need to save the giant battery, but I don't want it going dull on me while I'm testing it. We need to take a look at the pinout for these motor controllers. And what connections do we need from that pin header, and make sure that the right signals are on those pins. And then we'll get the oscilloscope involved. Momo, you are just taking up all my bench here. So basically, what I am bringing to the table here is making sure that, well, building an adapter is one of the big ones, but also just making sure that further crimes are not done against motor controllers by Momo himself. Let's make this screen friendly here. I'm going to make it a little bit more narrow and get rid of this panel. Can we get rid of that panel? No, we can just make this panel worse. Oh, there it is. Okay. So, motor controllers. Those are XESC left, and they are a bunch of different jumpers, aren't they? U6, 5, and 4. Okay. U6, U5, and U4 are the motor controllers. It's just a weird way to do it, but I guess it's fine. Everybody has their own conventions, you know? The hell? It is indeed KiCad, yes. You know, far be it from open source developers to use something that's not also open source to develop. U12, 11, and 10. 4, 5, and 6. Man, this is a nightmare schematic. U, V, and W for the phases, the Hall sensors. I had a course that involved partially KiCad. Interesting. I've been using Eagle for a long time. In some of my old jobs, we would use, what was it called? It was called, not Circad. No, that's, anyway, we had this different schematic authoring software, and it was kind of cool because it was made by like a normal human being, and so when you place stuff, you would have to like use their own parlance, their own language to do stuff. Like, what was it? It was place component, PC. place line, PL, would be, so that would be your tree of operations. So you'd be typing on the keyboard, but you would also be laying down all of your sort of vector elements that made up a schematic. It was kind of a neat little thing, but it was so specialized for that operation. It was probably not a good idea to be that specialized. Okay, so where our motor controller? Separate, is it a separate drawing? Robot connectors, ESC, ESC1, ESC2. But in robot connectors are all the ESCs. Yeah, it was too specialized, but it was when you really got going with it. Oh. When you really got going with it, it was like natural. This is weird. Okay, let's this is not normal for like electrical engineering. This stuff is a little bit strange. AV3, SWDIO, that's not connected, but then the whole thing is X'd out, so I don't even know what's what. Why are they all X'd out? why is everything crossed out on this fucking thing? All right, where's the real one then? Yard force schematic, bill of materials, yard force, that's the, okay, that's that. Bottom, silk screen, solder mask, edge cuts. So this is the whole schematic, okay. There's another schematic just for the ESC, it's not in here. It's in a different, like, thing. But it shouldn't, this should also have the connection to the ESC. Whoa, 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 whoa. Zooming and unzooming in on weird stuff. Because I'm just interested in the pinout. So is that this? No. Silk screen too large for motor sensor USB. What? Core. That's the core. It's going out to the UARTs and stuff. We're looking for the connector that goes to the ESC, which is still part of this hardware board, so it should be in here. And it kind of is. It's just crossed out. I don't know which is the right one. That's the LM7600. BQ25. It's two little FETs sitting out there, and it's little 10 microhenry coil. And then we got connector galore, likely the Raspberry Pi. And here we have ESCs, but they're all crossed out. Every single one is crossed out. Yeah, I would have done the schematic much differently. This is tough. PW, there's the 2605 CDVV. What else do we have over here? So these are all like the sensors and stuff that you can plug in. The Max, something or other. Okay. So again, these are crossed out. We don't know if they're correct. And it looks like they've got Hall sensors, temperature, phase, voltage from the battery. Don't know what that one's doing. Oh, VN and 5 volts. I see 5 volts to power it. Don't know if we're doing programming. We have a shutdown, a TX, and an RX. So I'm going to have to check. Okay, you got something in my DMs. Sliding on in to my DMs to give me crucial information. And filthy pictures. Dun, 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 dun. So this is the ESC. See, the thing is, like, when I'm looking at a schematic, the schematic is for a thing, right? We've got this board. That would mean that the schematic that I pull up is for this board. And so the connections to something like a Pico Pi or a daughter board would still be in it. And they'd still be labeled and they'd still all be called out properly because those pins are there. They're on this board. They're connecting to this thing. That's sort of my philosophy with it. And then if, you know, you would have Raspberry Pi as a call out because that's a sort of a daughter board. If you have your own custom motor controller, then you would have that as a different thing because it is a different thing. It would be your own schematic. It'd be a separate schematic that does the motor controller. And then on the schematic for this, I would have the same pins called out. Yeah, shoddy updated open source project. XESE schematic is the most updated. Okay, I'll take a look at that. Yeah, this is just, yeah, it's something where I'm not privy to all of the revisions and stuff that would happen to something like this. And so over time, let's just cross that out for now. Let's move on and do this. And so there's no, there's not exactly a governing body coming back in and going, hey, you need to clean this up. So it's what we get for open source. This is how we deal with it. Okay, so the XESC YAML. I don't know what that is. XCSB PCB. That's in KiCad. Oh, that's .pcb. I can't open that. Step file, DCM. Do we have a ESC2? The xese.sch. What can I open that in? Yeah, see, not putting these in here as PDF is killing me. Sure, that doesn't look shady at all. It's not going to give me a PDF virus. Where are we? XESC. Bomb, flip table, cache, diff, bomb, DCM, so PCB. Well, schematic is really what I need. Although opening up the PCB would probably... What the... And then, of course, I always fumble with GitHub. I guess I have to get the whole thing, don't I? I always fumble with this, and I know it's haha funny, can't find the download button, but there's always like, I'm not going to pull the whole project. I want one file, you know? So I don't really know how I can get the singular file that I would like to look at. May not be able to. I may have to pull the whole thing as finalized version 2.1. Sometimes there's like a download folder, right? But right-clicking doesn't exactly help me, and I'm just too dumb. Too dumb. Ha, look at him, he's dumb. This isn't dumb, this is a bad interface. But it helps keep GitHub organized, I suppose. XESC2, PCB design. I don't care about the PCB design. I want that schematic. So let's see. Robot operating system driver. And then it is up in... You got forks and stars and insights. Code. Guess we'll just download the whole thing. I hate having to do that though. Well, it's only 8 megabytes, so. It's the same way with the open wheel stuff. It's all really badly, oh, is it? About, readme, view license. And usually it's the big green guy. Yeah, 3 releases is where I probably should be getting it. Okay, so we are in... Well, hold on, what's up with the PDFs in here? Okay, that's the chip. And then standalone MCP2515 standalone CAN controller. Okay, that's not what I'm looking for. Boop. Not pretty. And then no PDFs in here. Yeah, okay. And so down here we've got the, well, there's a step file for it. Bill of material, cached, if not, Gitbot, KiCad schematic. Try that. Oops. You mean unsupported? Oh, SCH? Yeah, SCH. Oh, it's not. It doesn't actually have that. Where's the dots have been underscored? What? Why would they do this? No, get out of here. I like broke all my shit. Hold on, try again. You son of a bitch. I may even still have KiCad. I do not pay for WinRAR. Hold on, KI. No, I haven't installed it in this computer. Do you have something against it? No, I just don't use it. If I install it on this computer, it's just going to languish. I use Fusion 360 for my stuff, and I'm sponsored to use it by AutoCAD. It's just this is very KiCad brained project, and so they don't publish a PDF with their schematic on it, so I don't have any resource to take a look at what the damn pinout is going to be so I can get it working again. And it looks like everything here is working. I'm pretty sure it is. I would very much like to know what I'm poking, and this is very open source, and so I was hoping that there would be like an easy online converter, because sometimes there are. I don't need to know how to export as PDF. I don't want to install an entire piece of software to look at one drawing. It's one drawing. I just want to know what pins I'm poking. Well, regardless, I don't necessarily need to know exactly what I'm poking. I'm pretty sure my scope won't blow up with any of the voltages we're using here. So it is in plain text. Yeah, there's the plain text. And maybe if I get my a good piece of chart paper and a weird kind of ruler. No, all right, we're just gonna poke, and we're just gonna see if anything is out of specifications. I won't know exactly what those specifications are unless there is a pinout that is valid on this other schematic, the one that I can actually see, the one for the PCB, which does include this, but I don't know, does the X through it mean that it's not installed? I guess that may be what they're trying to convey. What I don't like is that they don't call out, they're just calling out like pin numbers, and like, this is not a component. This is a daughter board that's made up of multiple different connectors. So like, that's a different, it kind of bucks the conventions that I'm used to. So like, KiCad does have that info. I don't know what to do about that. Basically, multiple different individual components that are meeting to a daughter board. You could still represent the individual components, but group them together in a logical way, or, you know, give me some call outs in the silk screen here. I don't know how many people would be in the situation that I'm in where you have to poke individual pins to see if they're communicating, but I mean, there are conventions for a reason, you know. But yeah, if well, what if I do go to this guy over here, and maybe you've got like a pinout somewhere in here. What is this thing called? This thing is called the XESC. XESC pinout. Easy to use. I wonder if that's the Silicon Labs Explorer kit. No, it's not. Okay, so it's like locked into GitHub. I can't just easily get. Maybe on the internet at large I'll be able to get something. This is going to be the same page. Yeah, docs. That's just too. Yeah, I've already got this. I just downloaded this. So you take something like this and you just tell me what all the pins are. All right, so yeah, that's where we are. So I don't totally know what everything is, because I'd like to work with just an easy one. But if we install KiCad, which I do not know how to use, let's see how long that takes. Oops. What are you doing out here? Oh yeah, it's this one. Boink. For Mac OS. A gigabyte? I gotta download a gigabyte while I'm streaming? Ah! I do not have Rabaz speed internet connections here. Okay, iCAD. As soon as I open this program, somebody's going to jump in and say, why don't you use Fusion 360? Let's rename that file back to what it was, just so I don't get messed up as soon as I try to open it. Okay, that's all set. That's all set. Now we just need this. KiCad is like some synthesizer. You're going to learn? I don't know about that. I mean, engineers are expected to be jack-offs of all trade. You're supposed to be able to get used to these other programs just in case you go to a workplace that's using it. And I have tried to use KiCad before. I don't know if I love it. There's a lot of really good stuff that you can do with KiCad because it is the choice of open source. And so you can get all kinds of cool like plugins and whatnots for it to make it work good. But I have not bothered to really like learn KiCad. Ooh, I don't know if I want the libraries. Or do I need them to, I probably need them to view the schematics, don't I? We don't need demo projects. Don't need those. Next. All right, here we go. We wait on the green bars. I probably should have already had this installed, to be honest, but here we go. Although it would be nice if the open source project bothered to make a PDF of their schematic, because that would keep me from having to install this entire thing and learn how to use it in order to just look at one schematic. All I need is that pinout, because we're doing such a low-level overview of this thing. I'm checking to see that whatever we plug into this next doesn't explode. And then all I'll need is a pinout from the motor controller to, and then pinout from the old motor controller and then the new one. And then we just adapt them over to each other. I need to make a little thing that plugs into this to carry all that. Okay, launch. Launch KiCad. KiCad is that it has separate programs for each aspect of a project. Supposedly it's running. Oh, there it is. Configuration's missing. Let's take a moment to do some basic things. Oh, would you like to configure KiCad? Default. Start with the libraries, sure. Check for updates on startup. Yeah, okay. Finish. Okay. We need to get to the project. Oh, this thing's still loading. It's like, all right. Oh, there it is. Okay. Open project. Dune loads. And there it is. Does that work, or do I have to jump into PCB? Let me just open that. Nope, I can't. Yeah, so I have to jump into PCB, and then KiCad Pro. There we go. So, schematic PCB, and then the library. So the schematic. I don't know how integrated the PCB design is. In Fusion, I can click on the pin and it'll tell me what it's called in the schematic. That probably exists in KiCad, I would assume. That would make it a little easier for me to go pin for pin on it. Yeah, so the PCB editor and the schematic editor are different programs. Okay. All right, easy peasy lemon squeezy. Now I've got names of pins. Doesn't do much for finding what pin does what. So I'm going to assume, I'm going to ask you me. Oh, there's multiple sheets. Wait a minute. FET, sheet 16, ADC, power. And then here's the... Huh, that is not... Okay, let's go from the PCB then. Let's try the PCB. Yeah, the apps then link to each other. That's what Fusion essentially does. It's a little cleaner looking, but it does the same thing. Okay, so yes, I can get the identity of what these pins are directly from the thing. Okay, good. So let's start poking with Momo on. And I'm just gonna go pin for pin and just check to see what's there, what's doing, who's talking to who. Let me get a scope probe. I want to use, yeah, there's yellow. Get a scope probe with some leads on it so that I can poke directly into these DuPont connectors. The name is Dumas. What a dumbass. Okay, so there's power. I need my jumper for ground, and I think it's grown legs. Okay, we'll use this blue one over here. Blue lead will be ground. And then I'll put the scope up. Why do we have math on? Turn the math off. What? Why are purple? Oh, that's channel 4. Oh. Okay, there we go. We're just doing one channel scope on this. And so now I know that these guys on... Now, is this in the right orientation? It's not. It's like, are we viewing from below or above? Let's see. So we got this short one there. So it's a 180-degree spin. That doesn't do it, does it? That's for flipping stuff individual. I'm going to flip my view. That's refresh, I see. How do I zoom, spin? I don't think I can. Maybe we can flip Momo so it's in the right orientation. I'm just doing everything I can to not confuse myself. Yeah, so everything must be done to keep bother from being confused, because if I get confused, sparks fly. Highlighting a pin will highlight the other. That's what Fusion does. It'd be pretty cool if this does. Although I don't really need to see the schematic because these have logical names. So I sort of know what's doing what. Not on these. Those are net for something. Okay, Hall effect sensors from the motors, ground, V motor, 5-volt ground. These are to the 3-phase, those go to the big Molex connector. Ground, 5-volt voltage motor. Much like the power regulator that's used in this thing, for some reason they appreciate having power come in from two sides. I wonder if that's just so they can daisy chain them. Yeah, and so those are serial clock, MOSI, MISO. So these are the ones that we're going to look for the Raspberry Pi communicating on, and then we're just going to make sure that it's more likely, we definitely have ground continuity. I just want to look at whether or not the Raspberry Pi's been killed. I don't think it has. I think it's going to be communicating. So we're going to be looking at these two nets. We're going to look at 3D3 and make sure that that's nice and stable and clean. Voltage motor, we're going to see 24 volts on that. My scope can take it. It's just gonna be a bit. Yeah, middle button drags, but I don't think it rotates. I think I have to hit like a control middle or something. I don't want to click on anything and change any of the design though. I'm just going to use the tool as I have it right now, as I'm confident in using it, and not rock the boat. Unfortunately, I can't even right-hand mouse with this setup. Center click, left hand. Yeah, okay, we can do this. All right, so first things first, let's check VM against ground. And I will check with the multimeter because I don't want to give my scope 24 volts. I think the scope can take it. I just don't want to do it. So we'll go V over here, and then we'll check ground 5 volts VM. So that should be VM. When I turn this on, 24 volts. 24 volts. You guys can't really see, but I'll just get this one done quickly. It's 24 volts. It's just battery voltage. Straight up. Okay. These should be 5.09. Okay. Yeah, those are 5. Those look good. All right, so the voltage that's being supplied to the motor controllers, is it going to be clean? So let's get our ground, and then let me get my probe pin. Here, why don't you guys come over here? Oh, that's useful. It's kind of obscured by chat. Okay, so I'm putting a jumper lead on the end of the scope, and we've got 10 volts peak to peak, and of course my ground situation here is absolutely terrible. I don't know what does that. I think it's the lights, but if we check 5 volts, I missed the pin, there we go. That is a nice stable 5 volts coming out of this rockin' crazy regulator over here. Check the one all the way over here. Nice solid 5 volts. Nice good 5 volts. I mean, the LED's on too, so I don't think there's too much weird stuff going on. 24, probably, yeah, we can get 30 volts on the clock here, so there's 24 volts. That's looking nice and clean. Nice and clean. Just like Mama used to make. 24 volts. We got V on C1, 24.05. Yep, looking good. Okay, cool. Everybody online, looking good. Down to 6 volts, and we're coming over to the lower voltage portion of the board. And so I'm just looking over here. We have Hall effect sensor inputs that aren't plugged in. So I don't think those are going to have anything. Ground to ground, clean. Hall effect sensors, we're not getting nothing. They're just not. That was just me. Yeah, that's just me. Which one are we looking at? We're looking at the right motor. So that's this one. That was me hitting that's just me hitting this probe. I don't think we're going to get anything from the Hall effect sensors unless things are powered up. You got to power up the Hall effects. Okay, going on. There's 2 pins up here that I don't know what they are. Don't know what they are. And then this one should be 3v3. It is not. Now, is that a 3v3 input or is it an output? What are we 3v3ing on there? Because there's no 3v3 on this. Maybe it's not required. SWD clock. Technically, we should be getting an SWD clock. Checks SWD clock. That's actually, but that's for programming it. Isn't that SWDIO for the... Oh, is this using an STM32? I can't get away from the STM32, can I? I don't like them. They're too much. Too much microcontroller. It's like, yeah, this thing can do your homework. And I'm like, well, I want it to. Okay, so this is... we actually don't know. It's just, it is one of the digital pins, RX. Okay, so this is receive end. So we are sending packets of data, packets of data, packets of data. It's looking for the controllers right now. This one is SCK external. 6502. No, mine was the like 80 something or other. I forget which I took a course in. I literally had to put instructions on like write them down on a test to move bits back and forth. So that's MOSI. I don't know why we're just seeing that little lumpiness there, but overall, I would call that, you know, it's fine. It's within spec. It's 5 volts, you know, where TTL voltages, even though, wait, the Raspberry Pi doesn't, Raspberry Pi doesn't, wait, oh, that's 3. Okay, 3. We're at 3.3 volts. So things are looking, yeah, 8088, I think. We had the data sheet for the 8088, which is like 500 pages long, and at the end of it, you have all the machine instructions, and so move LW, move RW, all that stuff we had to get in there and program. This looks fine. I think we're doing okay here. I need the pinout for the GPS next. This will accept new motors controllers, and depending on what the pinout is of the new controllers, it should be pretty simple to adapt these pads. I'll have to make some proto board pads, but I think it'll be better to put less sensitive controllers on here. Otherwise, everything that it says has happened. So the explosion of the MOSFETs purely because of something physical, and I don't think it cascaded over to anything else that I can see at the moment. Let's check the GPS pins and just make sure that the GPS pins are doing what they should do. Let me turn this off. I have the GPS. What I don't have are the new motor controllers. The new Momo controller. Momo controller. Okay, let's see here. I got a couple things and help us identify what the GPS is. Helps to just have the damn thing in my hand. So yeah, it an absolutely worthy precaution to power things up piecemeal. Being cautious, because when something like this goes down, it'll take its buddies with you. He's got a little USB connector on him and everything. That's a nice motor controller, but man, can you get cheap ones on Amazon? You can get real cheap ones on Amazon for dirt cheap. Good deeds done dirt cheap. Man, everything they use in this project looks advanced. This is like some kind of a crazy Arduino form factor. And then it's got the little guy here. Your little like hack RF thing or whatever. Okay. What else do we got? This is just... There's something in there. Dead one? I don't understand why that would have... Maybe the capacitors at the top would have fried the rest of it. Yeah, the Arduino Uno. This guy. I guess they decided to shape their GPS board like an Arduino Uno. Yeah, with a pin offset and everything. And then this is a different form factor. I've got some radio modems that are that form factor. The 2 rows of pins and then the sort of like tapering in front. I've got a couple of them. I don't know where they went. The one on the red bubble wrap is good. So this is the good one. Is this the one that I had here? Is that the one with the bad FET? I don't see any cracked FETs. I'm going to assume that the heatsink hit these caps, which are connected to your power and stuff. And then, of course, it's an ARM microcontroller. So this one's the dead, yeah, okay. We're not gonna mess with those motor controllers because the cheap Amazon ones are cooler. 40 amps. She did. Okay, so now I want to see if... I'm not going to plug this thing in. What I'm going to do is just check that the voltages are correct for plugging something like this in. So I just need to know what the hell this thing is. What are you? Ardu Simple? GPS? Handle me with care. You shut the hell up. Before connecting a wire to me, check twice. Yeah. So Ardu Simple GPS, is that what we're looking at? $200? What the heck? That's expensive. GPSs aren't, well, I guess it's a good type of GPS, right? All right, Ardu Simple. RTK1, it's the centimeter precision that they're after. Precision GPS. Which one are you? Mosaic G5? No, it's not quite it. Which hold on. Where's this thing? Yeah, I've got a couple XBs. This is an XB connector on the front here. I don't know if you need an XB, probably not. Ardu Simple with an XB connector, but it's, I don't know which specific board this is. They really do label everything, which is kind of neat. Time Pulse, SafeBot, TX Read. One thing they didn't do is identify what product you are. Unless that's the serial number. It's like, what model number are you? You have literally everything else printed on the front of you. Oh my God, okay. It's on the back in the big white letters. Is that serial number the product number? That's S/N, that's serial number. Is it the 2202? Listen, two engineers doing the same task will do it vastly differently from one another. And complain about each other the entire time. And I know I'm 100% guilty of that. So the serial number is in fact the product number. What's up, loser? What? What do you mean you can't find it? Is that the right one? Doesn't seem like it. Products. Oh, RTK board. That looks more like what we have. Although they all look the same, so $215 is the right price though. And then lots and lots of info. One simple budget board. Can I see information about what you are? Basic starter kit without headers. The second you give me that information, I'm like already gotten it. I've already made an assumption. It's good to, yeah, it's good to have this though. Okay, so are these what I'm checking? Impressive resolution. Support. Oh man, I need just like not a tutorial. I don't need compatible software. Yes, I still have questions, but I don't want to talk to a robot. I need like your data sheet. You plug it into USB and it blinks. That sounds about right. That's what I used to do for a living. Let's see. I need to just see what the pins are doing. I think maybe we need this schematic. We need the big boy schematic to find the GPS info. It's one of these. Which one is it? Unlabeled. Ethernet, Ethernet, Ethernet. Exercise, exercise, exercise. Let's see. Big boy connector. Bot connectors. All sensors. All right, let's go over here. Looking for, there's the core. GPS. That doesn't fill me with this doesn't fill me with confidence. I mean, you know, we could just poke and I can make educated guesses based on things that seem to be connected. So if I look for, these look a little greasy over here. I'm gonna check to see that those get good, whatever it's supposed to get. Which I only know where the ground is, huh? I guess the rest of it is GPIO. So 4 pins up from the bottom here should be ground, and then we'll investigate the 2 that look a little toasty. But I think they're okay overall. 1, 2, 3, 4. And then that one, yeah, it's not, nothing's really going to be doing on a lot of these pins. They just seem to, they must have gotten brushed by an iron. Okay, so then what I'm looking for is first main power in. So we are getting our power from JORS. What the? TX, RX, RX. We've got USB coming in here. 5-volt in. It has to be in the middle of the header, right? So we've got a little broken header, and then we have, so broken header, this one isn't labeled. We have ground, clean, and then we have 5 volts. Oh, it's off. It's off. We'll turn, Momo, turn back on. 5 volts, steady on the clock. I can't see anymore. Ow! Okay, so we are getting good 5 volts. We are getting good ground. As far as digital communication lines, that one is, see, I don't know what that means. IORI. That one's unknown, but what, IO real. Oh, what? Hold on. Oh, IO ref. So the input-output voltage reference is set at 5 volts. I have concerns about all this 5 volts that's running into LM1117. That's running into a Raspberry Pi. No, different thing. So in terms of like checking these, those look okay. I don't know what IO is being used for. Well, probably TX and RX. So let's check those. That is just 5 volts. Which one is that? That one is TXI RXO. I hate that convention so much. Those are just being held at 5 volts, and it's possible that when Momo boots up, so we're gonna turn her off, turn it back on. No, it doesn't appear to be looking for anybody. See if any of the IOs doing anything. Who is this doing this symphatic type of alpha beta psychedelic funkin'? Nobody's talking to me. Nobody's talking to me. Nobody's talking to me. Nobody wants to talk to me. Nope. Nope. Oh, nope. Nope. That was reference anyway. Okay, so boiling it down, the GPS communication is probably pretty simple, TX and RX. We just don't have anyone to talk to right now because we're not plugged in. In terms of my diagnosis, you know, did the motor controllers blow up and take anything with them? No, not even any of the capacitors. These all look totally fine. Everybody on board looks good. Everybody looks like they're functioning properly. The GPS, I haven't tested this board yet, but according to my friend Habibi, if you plug this thing in, it blinks, which is all we can ever ask of any of our electronics. So let's plug this thing in and look at it blink and go, hey, that thing blinked. What do you do when you plug in a GPS? What if you miss? Doesn't have an antenna attached. This. So we're kind to our electronics. I could put a 50 ohm load on it too, but so there's a little bit of TX RXing, little GPS communication going on here. That's all we can expect. This thing would probably take like a day to get all of its satellites again, because it's now in a basement and it's been moved across town. Across town is still a little better than shipped, you know, to another international location. But when you move GPS, it will go off of whatever constellation it had seen before, and then try to approximate where its new constellation's coming from so that it can attain its location. And that's sort of the forensics of GPS, is that if you get some perps GPS, you can get what the last saved constellation was. I see. So the RTK locks it within 10 seconds. Interesting. 5 in a row. Oh my God. Paloozer, thank you so much for all the views. I appreciate that very much indeed. So I don't see any problem plugging this into here. I assume that there's just blinking lights when you do that. Is the RT, is that the military one? I don't think I ever messed with it. The like hacked military GPS that works super duper good. Wait. What am I waiting on? I will trust in my friend and not plug this thing in. Use the GPS software on that site. It isn't recognized via serial, which is why I think it's dead. We're working on Momo, who's a robot roll call. It's a robot lawnmower, and we're trying to fix it. Had the motor driver blow up. When a motor driver blows up, you can take stuff with it, because fets be fettin'. So, actually, I was shorting out a bunch of the pins. So what we're doing is we are plugging in individual components to test them. We looked at voltages on the board, and everything looks totally fine here. So, you think the serial communications is fried on this thing. So we need to test the serial communications on it. Verify that serial is indeed communicating. And I saw nothing here. What do I see if I go to Ishting? This isn't properly grounded, but it's trying to do stuff. Let's try to give it a good ground then. There's ground. No, hold on. Ground here. Yeah, I'm not seeing any TXRX, but nothing has initiated TX and RX, so we just need to see if the TXRX capabilities of that board are dead. So if we're doing that, then we go to this site, And we get... Oh, there's the... all that, and there's the data sheet. Jeez. I wasn't looking properly. We ship from Spain. What am I looking for? Software and apps. Windows. Wow, this is a lot of weird stuff. Let's see. What are we again? Simple RTK to be. UM98. ZX20. Oh, I see. This is close to your name. RTK modules. Simple RTK2B. uBlocks Z. None of this is language words. ZF9P. So this is the one that give. What the fuck's going on? uCenter. They say Ardu's simple, but this is Ardu complicated. This is gonna dox my location, so I'm kind of not too kind of not champing at the bit to install the software. Yeah, sure. Just install whatever. It's cool. Ah, there's a bug! Like a fruit fly. You guys coming in here, pushing me, making me download all this weird shit, install these programs. I was happy before today. All right, let's see what we've got here. Install this, get the thing running. I have to choose a language. What is this? Language? I have to choose a language? This is woke nonsense. I agree. Let's install it. Sure, why not? Here, just infect my old computer. Yeah, it's I'm touching it. That's what happens when I touch it. When I touch my oscope. That's a big old ground noise that I got running in the shop, and I think it's because of the LED lights that I used, but we put a big filter on them, so I don't know. I don't know anymore. I am going to connect, but I'm not going to connect with this visible. By choosing a language, you're adding to their metrics. Oh no. Let's see. So we need to give it the COM port. Store workspace, file, database. One of these is a connect button. There it is. I'm guessing COM3. And the speed, let's give it a big ol' 115200. COM3 MQTT client. Wow, it even does MQTT. Jeez. Let's see. That may not be the right port. I don't think a COM4, I think, is something else. Yeah. So, all right, let me unplug it and see which COM port disappears. Blink. Is there a refresh on this? Okay, it was COM3. But maybe I plug into the other port. Power and XP. Oh, I see. That's just for the XP. So yeah, plug back in. Choose your port. COM3. I see. So it connects when you select it. And then navigation private solution. What does that even mean? That would be for sending commands. This is why you think Serial is broken. Yeah, I mean, it's getting stuff. I just don't know. I have no idea what hot start, warm start, and cold start. Chart view, map view. I'm gonna do this and just see if it. Do I give him a map view? Oh, this should have like headings and everything on it too. Oh, that's cool. I don't know how to get that data in this program. Don't load any configs? Okay. I want to see if it gets GPS. It probably doesn't get any GPS down here in this RF chamber of a shop. That's receiver firmware update. Gen 9 configuration view. Don't know what the fuck. Creates a Generation 9 configuration view window. Yeah, I don't want to load anything that's going to change anything. Enable all debug messages, so we won't do that. So supposedly there are packets running around, and so that may mean that TX and RX is okay. You want to try to pull the debug terminal? Enable debug. Here we go. That was a lot of stuff. Well, it looks like we're getting data from that. View. Is there a debug terminal view? No. Table view. Well, you'd think the table view would be storing some of these things. Yeah, so this means that we're getting complicated data with it, which means that it's working. So then I can put that back on Momo, and then I guess all that remains is to get the motor controllers in here so that I can build some boards that'll adapt them over so that Momo has more powerful motor controllers. And then in terms of configuration and stuff, you'll have to figure that out. This is a scary interface. It has all this all this data. Crazy. Okay, closing that. Closing that. We're done. I'm done. So far, Momo has passed every test that we have put Momo through, which isn't that complicated, but it is all of the basics of how not to blow up your robot lawnmower. It seems that it is doing just fine at, why did I turn that on? Ow, turn it off. Okay. Seems that it's doing just fine in its individual components, and the voltages that it is able to express on all of its pins are all the correct voltages. And so the assumption at this point is that something is wrong with the motor controllers themselves, and that we can put new motor controllers in here that are cheaper, a little bit stronger, less prone to immediately just going, ah, and then blowing up. And so Momo will rise again. Momo won't boot with this plugged in. I think we're at a juncture where we should just try. So if I have Momo plugged in, make sure that those plugs are seated properly. Momo's plugged in to GPS. GPS has an antenna, so it doesn't hurt the internal modem. I've plugged USB in. I might unplug it actually for this test. Let's keep that unplugged. We have only battery GPS. Everything else is certified. Momo's ready to compete in BattleBots. I reckon not all of us are going to get out of this. Blinking. Will be blinking when they're saying, I get knocked down. What I gonna shut up, light? Ah, my eye. Jeez. Whew. What I can see, and again, you know, we got just solid red. We got blinking green on the Raspberry Pi. So the Raspberry Pi is thinking. So if I plug in USB, Pi is, well, I'm not seeing the green light flashing, but it's also just still, everybody's powered, and we got blinking lights coming from the GPS. You want to take a goody XESC and plug it into the slot. Now this one is not. This was the one that was loose. You're saying the one that's in the bag is good. Still in the bag. And it's got a little heat sink on it. Yeah, I got a bunch of these. So this one is like brand new. Doesn't even have a shiny circuit board. Nobody's blown up. It's got space for an extra thingy. And we've looked at the pinouts, and those are good. I'm not going to plug it into a wheel. I should do it on this motor. So that one is right, center, left. So center motor. I see. The programming header is there, but it doesn't actually interface. And that goes all the way up there. That goes all the way up there. So just like this. Okay. So let's see what happens. Oh, all this stuff isn't plugged in. We're still booting just fine. Raspberry Pi is booting up. Yep. Is this thing getting hot? We got a green light from the motor controller. You finished typing that right when I said it. Yeah. So, I mean, like, oh God, that light is so bright. All the individual components appear to be doing just fine. I was given a perfectly functional robot lawnmower. Yeah, we can go to the other slots. Nah, tape over the light. I'm not. I need to do that right now. I guess this thing, you know, there's no front panel. There's a lot of stuff that's still missing here, but these are the primary components we've got going on here. Ow. My face. Green light. And it should start doing its thing. Wow, we got a raid! Oh my God, that scared the shit out of me, man. Cosmo Quest raiding with a party of 13. We got to get the other raid light working. I'm going to work on that this weekend. The raid lights are something that we've added in order to make it more special when someone raids. How's it going, raiders? We're just getting to the bottom of this robot lawnmower, which is called Momo. There's Momo's little head. It's all the way over there. He's got the googly eyes with the cowboy hat on. That's Momo, and this is the chassis for Momo. This is a open source robotic lawnmower that uses a very sensitive, like centimeter sensitive GPS in order to navigate. You can do other sensors too. This Momo does not have too many sensors on them right now. We're viewing an IR. We do have thermal vision going into this thing that'll give us an idea if any of these electronics have a cascade runaway overheating issue, which, you know, heat is the death of electronics. It's not a vacuum cleaner. I keep calling it a vacuum cleaner. I cannot help myself. I'm dumb. Every time I say lawnmower, I have to stop and think for a significant period of time. Here's the idea light. Brilliant idea. Yeah, it's you know, there's some documentation for it. It's not quite up to where I would like to be. I need a big dumb drawing in order to keep everything straight. I had to install KiCad in order to just know what the pinouts to some of these are. One thing is I'm not seeing any blinking lights from this, but it's also not exploding. I don't like using this as a sacrificial microcontroller, a sacrificial motor driver board, but it you know, the green light is on. It uses slicer style algorithms to map your lawn out so you can really treat it like a 3D printed object. That's kind of cool. That's kind of cool. That's a weird side application to the technology. Very cool. Okay, 3, 2, 1, go. Nobody's blowing up. Give it the beans. Give it the volts, Gov. Oi, boss, give him the volts. Give it the volt beans. Okay, I'm gonna stop doing that. I'm gonna stop doing that accent. It's probably not a good idea to do that accent. So I'm not plugging in any motors to this thing. If I mean, I guess if you take it piecemeal and plug things in bit by bit, but I think a good solution would be to put a stronger, less blow-uppy motor controller on this thing. Cheaper one that doesn't have 12 brains. This thing has got one. It's an STM32, but it's not exactly small. Yeah, so maybe we make an adapter board. Now I know I don't need to adapt these back pins. I just need to go these 2 rows and then those double row headers. Yeah, we'll have to figure out getting them over here. Mopar or no car. What are you just typing into my chat, Haystack? What are you doing? What is this? What is this? What are you trying to say to me? Using language words. I just locked it. I locked it. It's locked. Okay, now I'm in. I'm in. All right, so these go there. This goes over here. These are the dead ones, I think. Although none of these FETs quite look dead. I don't know what could have gotten that one. Is there one of them that's blowed up? Dun, 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 dun. Yeah, they don't look blown up. If you plug the top half of Momo in, you get a custom MP3 greeting when you boot. All of them are blown up except the one in the red bag. I see. Yeah, they're surreptitiously blown up. Huh. And then we've got a replacement. I got replacement FETs in here, but I don't think it's going to be worth it to replace the FETs. I think what we should do is just make an adapter board because it seems like everything's doing fine. Blow it up to make sure, you know. You know, no, nah. I could replace FETs, but that's going to be more of a pain, and I think it'll be better for longevity if it has an interface to a more modern controller, because I think, have they come up, are they like, do they have standards for those now? I would hope they do. Oops, I just hid chat. Come back. Oh no, that's the scope. I hit the right button. Yeah, I would hope that they now have, you know, we have to like pin out expectations from these motor controllers because they try to make them universal, but you know, then somebody comes along and they make their own custom motor controller that has all the same features as a regular old motor controller from China. It just maybe speaks a couple different packets of language, and you know, further and further we try to standardize these kinds of things, because when you're out there in the field and you're racing your RC car against other RC cars and yours blows up, you want to be able to go to their sports shop and just be able to swap something in. And you know, it's the same thing with other systems of technology like we have here. I'm gonna hesitate. I'm not gonna plug in the motors yet. Maybe we'll just leave that unplugged. And then all the sensors will have to. I numbered all the cables to go back in the right spot, but we're gonna wait until. Yeah, when you make another standard, the XKCD comic. Now there's N+1 standards. All right, Momo, you're getting kicked out of the shop again until we get those motor controllers in. I can lay out headers and do all kinds of other stuff in order to prep. Actually, before we do that, yeah, maybe I should make. I'll make one of these, but the problem is, yeah, we gotta disconnect the battery. Gotta make sure. puppy! No! Yeah, we gotta kick the puppy out after this, just because I don't have space for it. Where am I to put it? Oh my god, just to make fun, I could do all yellow headers. Header there. Header there. Then we got these over here. See, the thing is, like, the, ouch. Well, hopefully these line up with 0.1 inch, but I don't know if they will. Bum, 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 bum. Bum, bum. I'm going to make one of these so that I can actually create these boards separately from the chassis. Get that to plug in without, no, I need to have that front row reduced. So what I'm thinking is that I'll have a proto board like this on here and sized properly, right? And that's just a blank canvas, and we can put connectors on that that'll connect to the motor controller. And I don't know what to do about the high current stuff, but that'll be manageable. We'll be able to manage that. Assuming that this is created at all on anything resembling a 0.1 inch spaced plane. It seems kind of like parts of it were. Parts of it, no, though. That's not plugging in. Oh, probably because of the overrun on the board. So we find one of these that's been chopped up. That's not chopped up enough. I need it to be all chopped up. Here's a chopped up one. Just make sure those two line up. Okay, they do. So those are all on the same pin spacing. Well, no, the point is that I have something that I can attach all the stuff to. I'm not going to use the dead one as a base. I need to start from a blank slate so that I can put things like connectors on it. So that if you have a future motor controller that shits the bed, then I will be able to swap in a new one easily. Without robot surgery. So my next question is these guys. These seem like they're not adhering to a 0.1 inch. So let me find some dummy header here. Just need a couple pieces of dummy header. Where is that? I mean, I guess I could put one across it, but do like this. Yeah, that is not compatible. So, what to do there? Well, we don't necessarily need those two front grounds. So if I, oh wait, that's not, it's because of this, it's not going down. Let's see here. Yeah, there's no way, that's not aligned. Okay, so then the other thought would be if I didn't, because these are ground up here, and then we've got other grounds back here. But those are the big grounds that I think are being used for the motor controller. So that's 2, 2, and 2, bringing everything into here. And then these would be for daisy chaining. So if I cut a hole in the board and just have these exposed, I could have those on little sections of wire that would plug in on their own. But is this stuff, it's not aligned to themselves. So it's I'm going to have to get a little creative here. Yeah, I hate it when they do stuff like this. Oh, wait, what happened here? Now everybody's lining up? Are those like... Wait a minute. This lines up with this. That's wait a minute. No, wait a minute. Wait. No, wait. My hair keeps passing in front of the desk light, and I keep thinking like something is running around. Like, the creature's loose. Okay, so the challenging thing here is that the header spacing is stupid. If I were an aficionado of KiCad, I could probably make the adapter with my own plugs and then send it off to a 5 for $5 circuit board place. But maybe I could get the dimensions in Fusion, but I don't really know if I want to do that in Fusion. I'd rather just do it with prototyping board. And then what that'll be is basically green board sits here, and then the motor controller will just like tape to it, and there'll be a basic like conversion to the plugs that go into the motor controller. Hopefully in the form of a plug. Now, do I have any surface mount pin headers? Because those could actually fit in. I don't have any surface mount pin header. Well, this is the wrong kind of surface mount. This is the kind that surface mounts by like bending down to the surface instead of so the pin headers, there's a type that will go to a flat board, although it's not as that won't really work out. I was thinking if I could sneak a surface mount pin header in there and then it would like allow it to solder to a non sequitur. That's not going to work. All right, well, anyway, I have some stuff to figure out. I guess we're done with Momo for the day. I don't really have much else to plug into Momo here. Here's my only 2-row header, but it's got solder all over it. I need to buy some 2-row headers, I guess. They're not totally necessary. You can double up on the 1-rows. It's just a little sloppy. Okay, so that'll eventually get a PCB. I don't know why that's not plugging in. Supposedly it fits. Oh, it's because it's all busted up. It's all busted up. So I got to cut 3 PCBs. I got to size them up. I got to get headers on them, and then I have to figure out how the high voltage stuff is going to connect. And I think it's probably going to be a little bit more direct. I don't think I'll use any type of like a plug or anything like that to connect it to the motor controller. I think those will go direct because they're pumping a lot of electrons back and forth. So that'll be the strategy going forward, is I need to make 3 bases and then figure out how those will make their way to the top, whether or not it's just a wire coming off of the ESC that goes into a header plug in there. That's probably what we'll end up with. And then basically it's up to my friend thinking of what is that called again, that movie? Friends for eternity, glory, loyalty, honesty, with friends together through thick or thin. Early Red Letter Media movie, and there's just one scene where this girl's brother was like super mad at her, but like it was totally disproportionate to the responses. And she said, "Where were you? I was seeing a friend." A friend! That's what I think of every time I say friend. I don't know why. My brain is broken by the internet. The internet has just permanently overwritten certain interactions and responses. It's bad. Anyway, Momo appears to be completely healthy. At least from my low-level poking around, all the voltages that should be there are there. All the intercommunications are there too. I see digital signals running over to the motor controller boards. I see digital signals running. We didn't really check, but the GPS was communicating with my computer. I don't think the Raspberry Pi's TX and RX is busted. Actually, before we put that to bed, let's put that to bed. Let's just make sure that we see GPS communications there. We got to be thorough, if anything. That's why people hire electrical engineers, because they're thorough about stuff. We can't be dumbass, slacking. We can't be me, is what it's essentially what I'm saying. So I'm going to go to ground here. And then I'm going to tap the TX and RXs over here, and we'll just see what we get. Doink. What? No doink? Oh, I undoinked it. Wait, I gotta redoink. We gotta redoink. You are now doink. Miami Connection. Thank you. Yes. Good movie. Doink. And then we check TX. There's a packet. Okay, that little burst. Oh, look at that. It's like, what the hell? Oh, it must have powered down. No, it's still going. We saw a little burst of communication there. Well, that might have been it. It might have just been like, nah. Oh, there it is. There we go. So that's a little burst of comms at a high serial speed to the degree where we don't really see what's going on. It's just, but you know, if I triggered this thing properly, if I sped it up, we would get, here, let's see. Nothing. Good day to you, sir. There it is. See, it's triggering off camera, but every now and then it'll be in view. Nope. Okay. This is so it's off screen. It's triggering like over here. So if I zoom out, as in changing the speed, see, we see it right there. It just goes. Now it's off camera. Doink, doink. So anyway, that's what's going on. We've got serial communication going on just fine. Made sure that, you know, blinking lights doesn't necessarily, God damn it. Blinking lights doesn't necessarily tell us that everything's good, but it seems like everything is good. Momo has been healthy. It's just the motor controllers that were hobbling it and keeping it from communicating. Now the motors are speaking what? SWDIO? No, they're speaking SDIO? What were you? Misomosi serial clock, something like that. It's speaking its own like serial. So if the new motor controllers are compatible with that serial, we're good to go. I mean, as long as they appropriately use all the Hall effect sensors and all that stuff to the same, you know, tune as everybody else. The only other thing would be to get the right specifications into the motors, but I guess that's in Momo's brain. So not the motor controller necessarily. I don't know how this works. So yeah, if they're all compatible, then I can just make an adapter board, and then when we plug the new motor controller in, it'll work just the same. Only it'll be able to handle larger current spikes. So that's the idea. And I guess until then, I have a little bit of hardware that I can set up ahead of time. And when I get the motor controllers in hand, I'll be able to actually do this. So let's unplug Momo. Momo's getting kicked out of the shop to go live on the streets, the rough and tumble streets, as a robot cowboy. Momo is not table stable. I need Momo to be table stable so I can actually put this thing down. Stool caught my mic. All right, so I got a little work to do. I'm gonna go do that. I will be back probably Tuesday. I don't know if I'll do a Saturday stream. Poor Momo getting kicked out. Listen, there's not even room for me in here. There's not even room for me to exist in this shop. It's all coming crashing down around me. I have to work on my tester module. I got to do Momo's proto boards. Those won't be too bad, but I still want to get ahead of that. I need to finish building a couple of the filters that I've got going on here. And you know what? We're going to keep working on projects. I don't know what precisely we will do on Tuesday, but I should have something cool planned. We'll see about that. I've got all the modules out of my modular synthesizer right now because I need to like clean them up just a little bit and just make sure that everybody is working in harmony with one another. Add some filters to it, this and that, and the other thing. I got to do another modular addicts order. And then we need to do the pick and place. With the pick and place has not had any progress on it. I have not overcome my vertical axis. I need to figure out how to stabilize a vertical axis and kind of make it very lightly drop down and barely fight back against gravity so that we can pick up tiny little parts and place them on tiny little boards that'll make tiny little wibbling noises inside of synthesizers. So I invite you to join me for all that. Until we come back, I could raid you guys into another channel. We had Cosmo Quest X raid, which I really do appreciate very much indeed. Paloozer That was a 5-stream streak. Why am I announcing that? Dr. Plugger resubbed with 63 months yesterday. So there's been like no activity on the channel. I'm totally fine with that. It's fine. I appreciate you guys coming in and tooling around with electronics with me. Let's see, Ua was playing Minecraft. So I don't know if I'll raid into Minecraft. Let's just take a look at Twitch, my front page real quick and see if anybody is around. Djibouti Show is with Milton and TechSmith, and they're playing Mecha Chameleon, which I love that game. I think it's an amazing game. Have I had a chance to play it? No, I haven't. BitLooney is doing stuff. If you guys want to check out BitLooney, see Ghost Freak and the usual people on a Friday. What's Womble doing? Going to do a community game. Oh, okay. Well, anyway, my recommendation is Djibouti Show because I'm going to be hanging out there if they don't stop going live soon. They went live super early today, around like before noon, so that's very strange for them. But anyway, yeah, have a good weekend, everybody, as we roll into the weekend here. The end card is right yonder. Doink, 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 doink. And we will be getting into great and excellent things next week. Believe me, we'll have a great time. In the meantime, I have to go out into the smoke and I guess walk the dog, but it probably shouldn't be for too long because, man. And then what I'm going to try to do with stream visuals, I want to have a weather thing that doesn't dox me come up on screen. And so I'm going to work on a little like Node-RED stuff. I don't know if we'll do that in the form of a dashboard or if I'm going to send numbers to OBS and have it put them up on the screen. I wanted to have an air quality index, like a live air quality index up on the screen. And I think I can do that pretty easily, but I got to get into some new stuff. So it'll be pretty cool to do because then we can make Burn the Subs do things like tell OBS how many names are burnt onto the board. So we can have like BTS stats that come up on screen and they're actually like accurate. I think that'll be really cool. All right. Anyway, catch y'all later. Doink, doink, doink. What am I? No, we're going to